Frequency encoding. Frequency encoding is something where each category is replaced with the frequency in the dataset. It's useful when frequency of categories carries some predictive power. This encoding is useful when we want to retain information about the prevalence of each category while avoiding potential outfitting associated with direct or indirectly involving target in the encoding. When the dataset is relatively small and dimensionality reduction is a concern, we can use this frequency encoding. As we can see, it's simple, preserve cardinality, and interpretation is much easier. But there is a problem with this. It may not capture the relationship. Outlier information cannot be captured here correctly. It also doesn't support ordinality of the data. Now, let's take a quick look at one simple example. Here we have dataset with 10 records, temperature and color. These are the two categorical variable, and we have target. Now, first what we will do, in case of temperature, we will see what all are the categories. We can see there are 4 categories, and we count the numbers of these categories. So hot has 1, 2, 3, 4. That's why the count is 4. Similarly, cold 2, very hot 1, and warm is 3. And if you see, since there are total 10 records, if you take a frequency 4 divided by 10, it becomes 0.4. Similarly, all others, the frequency we calculate. Exactly same way, the color category will have 3 categories, and this is the count, and the frequency is like this. So after encoding, we'll replace the categorical values with these encoded values. Now let's take a look at code. Frequency or count based encoding. Here we will be using either Pandas built-in features, or we will be using category encoder library or feature engine library. Let's look at frequency encoding. Here I'll be using Pandas to build a function, and then we'll be encoding features. So same dataset with the temperature, color, and target. We load into Pandas data frame. Here I am creating a function which take a data frame, and also we give the column name. What it will do, it will calculate the frequency based on that column name. We take the data frame column name, we use the value counts, and most importantly, use normalize equal to true, which calculates the relative frequency against the entire dataset. And as a return function, we map each row for this column with the frequency that is being calculated. Here we will be encoding temperature and color. In both cases, we pass it to this frequency encoder, the function that we have created. So after we run this, this is the final encoded dataset with the new columns created. And we can see the temperature frequency and color frequency both are like this, as we have shown in our explanation. Similarly, there is a built-in function under feature engine. So we first import feature engine dot encoding, and we import the count frequency encoder. Same dataset. Here the count frequency encoder is being called, and the encoding method is used frequency. Since this encoder support both count and frequency, here using the frequency one. And the variables we are using here are temperature and color. So we do the fit transform. After the encoding, the encoded dataset looks like this, which is matching with whatever we expected. Similarly, we can use category encoder to create this frequency encoding. Category encoder don't have a direct implementation, but we can use count encoder. So first we load all the data in the data frame. Then we initialize count encoder for the two columns that we want to convert, temperature and color. And most important, here we will be using normalize true so that we can get the frequency. So we do the fit transform, and again we can see the values are calculated.
That's all for this video. Thanks for watching. Don't forget to like, share and subscribe for more exciting content on machine learning and AI.